Alrighty, well hey, let's get some tool paths cut, and let's see what this thing looks like after CAD renders it. Okay. Excuse me. Alright. Our first tool path will be our outer bevel. Excuse me. We said we were going to do it with a 90 degree to give it a really nice outer edge. I'm going to put that bevel in at 125 thousandths. Okay? I'm going to cut on the outside of the line. We're going to run it in conventional. And we will rename it outer bevel. Okay. Calculate. Now, we're going to come in. I'm going to do our inner. Our inner bevel, we're going to do it about 90 thousandths. I want it a little bit lighter. Feel free to do your depths, your cut depths. If you want a more aggressive bevel or less, you do your depths for what you want. Okay? This will be our inner bevel. We'll calculate him. Wow. Alright, now, that is about it. This is really only a two tool-bit job. Next thing we're going to do is we're going to pocket out these. We're going to go to a pocketing tool path. Now, we had mentioned earlier that we're dealing with 1-inch material. Okay? Now, I'm going to pull the calculator up. I'm going to try to talk as clearly and as slowly as I can. I know that from the bottom of the clock face, from the back side of the clock face to the very front of this frame, I need a 3/8 gap. Now, I know that my bars are 1 inch thick. I'm going to take 1.0. I am going to subtract 0.375 because that is the gap that I need. That gives me 625 thousandths left over. Now, I'm going to take that, and that's basically the pocket that I need to mill in not only the frame, but also the back of the clock face. Okay? So if we take 625, we divide it by 2, obviously, we come up with 312 and change. Okay. So what we're going to do, we're going to come in here, and we're also going to come in over here, and with an end mill, I'm going to go in 300 thousandths. These will be my bar pockets. I will hit calculate. Alrighty, now we're ready to start cutting out. The next thing we're going to do is our bars that we nested. Again, we go into our profile tool path. We need to change this out. We need to go back to an end mill, 1/4 inch end mill. Click OK. The other thing I'm going to do is I'm going to change my speed. Now I'm doing a cutout and I'm not doing an engrave, so I'm going to slow him down a little bit so as not to snap that bit. Alrighty, now we're outside of the line to the right. We're conventional. I need to add some tabs. I'm thinking 6 tabs per will be fine. Okay. And feel free to sort these around. Or actually, I could probably just get away with 4. Alright. Get your tabs roughly where you want them. You may have to add more, I'm not sure. But if you do, that's no big deal. There you go. Pop, there's one, there's one. Yeah, we'll put in a couple more just to be safe. There we go. No rhyme to reason. Okay, now, I know that my material thickness from where I set my job dimensions over here is 1 inch. I'm going to take these. I'm going to call this cutout bars. Okay? I'm going to set my cut depth for 1.010. Yeah, we're going to cut through, we know. Great. Now, that toolpath is cut. But we now also need to cut out the middle. Okay? So we're going to go here again. It's remembering what we had just entered, 1.1 inch, 10 thousandths. The end mill, it's going to take 8 passes. Now, if we don't pay attention here, this can come back to bite us. Right now, this profile toolpath on this inner is set to cut on the outside. Well, if we did that, what it would end up doing is it would reduce our 1 inch overall. So we want to cut on the inside. We want our bit cutting out on the inside of the line. Alright? We also need to add more tabs. Okay, so we've got a total of 4 there. We'll throw in a couple more. Alright. That should do a pretty good job of holding things. Always double check everything. Your starting depths, your cut depths, because it is really a shame, and I've done this a few times. I've gotten halfway through a job, I've loused it up, and I've had to scrap the job because I couldn't salvage it. Because of what I did here. And because I didn't catch it up in my shop on the equipment. Okay? We'll call this inner cutout. We'll calculate it. Okay. Great. Now, last but not least, we cut out our part finally. Part cutout. Now, again, we want to go outside. Now, this is something else we want to remember. We've got a bevel. Okay, we do have a bevel on this. I'm going to offset. My rule of thumb is I'll take whatever. I put my 90-degree V-bit in. I milled this down to 120 thousandths. I'm going to take half of that, which would be 60, and then I'm going to reduce 10 thousandths off that. I'm going to offset my cutout by 50 thousandths. If you don't offset, what will happen is you'll cut your bevel out like you never had it in the first place. So, okay, we're going to add toolpaths here. We're going to edit them. We'll put in 10. We add our tabs. Okie dokie. Slide our tabs over. Okay. Alright. Let's calculate. Okie dokie, there we go. Now technically this whole job, let's preview all our toolpaths. Our material, well, we said we're going to use maple, so that's what we'll set it on. Great. Okay. And we're going to preview all our toolpaths. Now, general color, I use black. I set it for all. Okay. There's our bevels, our slots, our nested pieces. We cut out our center. We cut out our edge. And pow, there you have it, boys and girls. There is your entire clock frame right there with your bars nested in the middle, your pockets cut out on the side. There we go. Alrighty. So what we're going to do right now is we're going to save this as a demo clock. It's a demonstration clock. I've already got it. But that's what we're going to do. And don't ever be afraid to save your work as you're going. Things can happen. And the last thing you would want is on a really big in-depth job, things can happen. Especially where I live, power can go out. It's not likely, but things can happen. So save your work as you go, and it'll be some smooth sailing. Now, I'm going to stop for today. I've got a pile of editing to do. Tomorrow we're going to get back on our clock face, and we're going to show you how to get the clock face to work in all of this. Alrighty. Well, for now, thank you guys. This has been a long video, but I appreciate you hanging in and checking me out and checking out the video. And well, good morning. Welcome back, everybody. In front of us, we see the VCarve Pro software is up. We see a big white box, which is going to be our clock face, and I'll show you what we set our job dimensions at. Because the actual diameter of the clock is 7 3/4 inches around, I opted to go with a 10-inch by 10-inch piece of material. Again, I use mainly an inch thick up here in my shop. I buy rough cut. I plane it to an inch, and if I need it thinner, well, I replane it some more, okay? My datum position is always in the middle, and our unit of measure here, for the sake of this video, is in inches. Okay, now, we'll pull our print up real quick. I will bring it over, and I'll show you our clock face. Now, again, we're 7 3/4 inches in diameter. We're showing a 3/4 inch radius on the outside. We're going to use a bevel. We're going to use a 90-degree V-bit to make a nice bevel. If you want to use a round over bit or a hand router or something, that's entirely up to you. But for the sake of this video, we're just going to bevel our edges. Okay? Well, we need to create a circle for our clock face. Like I said, we know it's 7 3/4 inches, so it is 7.75 inches in diameter. We're going to apply that. Okay? We're going to transform our objects, and we're going to bring you up to a line material, and we need this dead center. This is now fairly crucial because this is the back side of the clock. We'll get to the front in just a minute, but this is the back. Now, we need to make sure that those bars are going to line up perfect on the back side of this clock face. The best way I can show you to do that is just like in another video we had, cannibalizing programs. I believe it was cannibalizing your CRV file, something like that. What we're going to do is we're going to bring that clock frame in. Now, mind you, we have saved that. What I'm going to do is I'm going to bring in just the tool paths, okay? Clock kit, fabricated clock, and we're going to open it. Now, you see it highlighted right here. That's the exact frame that we put together in the first half of this video. What we need is we need this pocket and this pocket right here on the back of this frame so everything lines up perfectly. The best way I can think to do that is we light it up. Okay, we bring it in. Let's get it aligned. Okay? Now, we can see we have a bar slot and a bar slot. Now, what we're going to do is we're going to get rid of everything else we don't need. Now, mind you, we have saved this CRV file as something else. We're not going to lose it doing what we're about to do unless you would overwrite the program in which we just took the frame out of, and you overwrote the face frame with this whole job, then yes, you will overwrite the original program. But we're not going to do that. We're going to highlight this. We're going to delete the frame. What we still have left is, this is one of the bars that was nestled in the center of the clock frame. We also need to delete that. Pow, he's gone. Now, these two bars we have not moved. What we can do is, because the distance between each one of them is not being messed with, all we need to do is center this in the material. Oh, excuse me. Here we go. We come down to Transform Objects, Pow. This is now centered on the back of the clock face. Everything is dimensionally right where we need it. Awesome. Now, with our slots in place, the other thing we need, again, we're using 1-inch thick material. You may opt to use 3/4. You may opt to use 1/2 inch. We need to go over to the website where we're going to be buying this insert with the pendulum for this modular wall clock. Okay, now, in your diagram, I'll also drag the blueprint over and I'm going to show you your shopping list. Okay. They're telling you that you need a quartz pendulum movement. Oh, it includes the mounting hardware and pendulum, yeah, okay. They're calling out for number 11090. Well, I'm just bringing this to your attention because if you were to order, in fact, 11090, which is right here, you have a total shaft length. Now, your shaft length is the threaded shaft that comes out of the face of the insert. 5/16 is not going to be long enough. That overall shaft length is not going to be long enough to go all the way through the face of the clock. You're not going to catch any threads unless you pocket out the back of the clock. Well, we really don't want to pocket it out that deep. So what we're going to do to save time and milling and this and that. Now mind you, all these inserts are the same cost. What we're looking for is something with a longer shaft length. This one's 5/8. Oh, well, we come down and we look at part number 11094. All of the characteristics line up. The shaft length is a little bit longer. Well, it's a lot longer. It's 1 1/16 inches versus 5/8. The dial thickness, instead of being 3/16, and this would have been the plastic clock face that we're going to show you how to do away with that. Okay, all wood clocks, they look nicer anyways. Your bob diameter, your pendulum bob, instead of being 2 1/8 inches here, it's going to be 2 11. You pretty much get the gist of all this. We want to match up something with a longer hand shaft length, but it's still going to come close to what they were calling out for. Okay? So we know that we are going to, in fact, use part number 11094. Alright. Now, if we look at the total shaft length, it's calling out for 1 1/16 of an inch, but that's not all threaded shaft. I can personally tell you that about 1/4 of an inch of this, okay, is in fact where your hands fit on. So we are still going to need to pocket out a little bit of the back. Now, we also need to know how big is the case that insert, what are the dimensions of that case, that pendulum case, that clock insert case? Well, it's 3 7/8 by 2 1/8. Okay. Well, we're going to now pop another pocket, but just deep enough so that we can just get a few threads sticking out the face of the clock. Well, 3 7/8 is 3.875 for the height. Well, we're going to go a little titch bigger, okay? And our width was calling out for 2 1/8. So 2.125. Well, we're going to also make that a titch bigger, and we're going to make that 2.25. So 2 1/4 by 4 inches high. All right? The other thing we need to know is we need this dead center. Okay? Boom. There we go. Everything is now centered. There's still plenty of meat around the bars. Nothing is going to not work here. All right? Everything's going to be fine. So we need to also find out what our shaft diameter is. Well, our shaft diameter, they're calling out that the threaded shaft that's going to come through, they're calling out for 5/16. Okay, I know that this lesson really doesn't apply to a lot of you older guys who've been doing this a while, but it's to help the new guys out. Okay, 5/16, we take 5, we divide it by 16, and we come out with 312 thousandths, okay? I make my hole a titch bigger, okay? Like I said, better have a little bit more. Okay, oh, and we take that to 325 thousandths, we apply it. Once again, we want our circle dead center. Alright, Now we've got all the punitive stuff on here that we need. We've got our mounting bars. We know the outside diameter of our clock. We've got our pocket that's all set for our insert to drop in. And we've got our hole for our threaded shaft that our hands will obviously sit on. Now, let's cut our tool pass. Alright. As we stated earlier, doing the face frame, that I use 1-inch thick material. We showed you how to run the numbers and do the math on the calculator right there for you guys to see. Now I know that with my 1-inch material, my blueprint calls out for 3/8 of an inch between the back of the clock face and the front of the face frame. Well, with 1-inch material, it left me 625 thousandths left over. We divide that between the pockets on the frame and on the back of the clock face. We're going to pocket these out, just like the face frame, at 300 thousandths. Okay. These are going to be bar pockets. We're going to calculate them. Great. Those are done. The next thing we're going to do is we're going to calculate the pocket that we are going to need to put our insert in. Now we know we have 1 1/16 inches. We know that this particular, and we'll bring it back over really quick. We know that this one with 1 1/16 inch is capable of handling a maximum dial thickness, the thickness of the clock face, of 9/16. Okay? Well, what we're going to do is we do not have to take and fabricate this down to a 1/2 inch. Okay? We are going to take, and we're going to pocket and we're going to call this the clock insert. It's the clock insert pocket. Now, if we do the math real quick, we're trying to keep this a good learning lesson. We know that our material is 1 inch thick, 1 point. We know that we have the capability with that insert of going through a maximum face thickness of 9/16. Well, once again, 9/16 works out to 0.562. So we're going to subtract 0.562. Okay? That's going to equal 438 thousandths is what is left over. Now, I know that if I pull, let me find my little picture here again. I know that when I look at my total shaft length, I know that this is roughly 1/4 of an inch sticking out. The hands are thin, they don't need a lot. But we still need a couple threads to come through. Okay. We're going to minus that 1/4 of an inch. Okay? That leaves 188 thousandths. Well, 187 thousandths is 3/16. Okay? And that's what we're going to pocket this out to. 187 thousandths. You can round up if you want. You can go 200 thousandths. It's not that critical. We just need to catch a few threads. Okay? We're going to calculate. Good. That is now done. The last thing we need to do is our hole. We're going to use a drilling tool path set with a 1/4 inch end mill. And this will just be center hole. Okay? And we know we're going through 1 inch. We're going to go 10 thousandths beyond, so we poke all the way through. Yeah, we know we're going to go through the material. We click OK. Great. Well, what we have just done, ladies and gentlemen, is we have just finished the back side of the clock face. Your mounting bars, your clock insert pocket, the center hole for that clock insert. However, we did not do anything with the outer ring. This is because this is the back side of the clock. We're also going to take this up to the shop, and we're going to practically show you this, whether I shoot it in video or we give you guys stills with photos. But regardless, you'll have something visually to go by. Now, we need to take and we need to save this program. Well, I opted to save it as clock face backside. Okay? And that's how That's how I'll save it. Now, with that being saved, we can now go in and we can delete all of this information. We have saved it, okay? And again, you don't lose it because it's saved. We now need to do the front of the clock, okay? Well, we can take these operations and you can delete them, okay? Delete them all, get rid of them. I told you I want to put a nice bevel, okay? Well, I use a 90-degree V-bit. Some of you guys may have 100, 120-degree V-bit, 60-degree, whatever you want. Maybe you don't want a bevel at all. If that's the case, you can skip this step, okay? I want my outside, I want my tool path to be outside to the right. I'm going 120 thousandths deep because I like a nice bevel. Okay, and we'll call this outer bevel. Okay, outer bevel. Okay, we're going to calculate that. We'll close it. Great. Now, excuse me, you won't see it because this is the face. The hole was cut through from the back. I can, just for reference, take and put you guys in a little 325 thousandths hole if you want. But it was cut on the back side. Okay? We'll take it and we'll center it. Okay, that will be the hole as it will appear from the drilling operation on the back side of the clock. You can save it and do it on the front if you want. That's up to you. But all right, we got our bevel with a 90-degree V-bit. The next thing we need to do is we need to put a face on this. Well, lo and behold, I'm going to include a couple different clock faces with this for you guys. Okay, we'll put a little ticky mark face on it. All right, and here we go. We imported the EPS file. We need to center it. Okay. Now, I know that the outside of this clock face is 7 3/4. I want to measure this. I'm going to go to Transform Objects, Set, Selected Object Size. Well, right now it's only 6.65. Let's take this to, and also make sure that your link X and Y are on. Okay? We need this dimensionally correct. We're going to go 7.25. And we're going to apply it. Now you can see that we're off just a titch. Let's uncheck this. Okay. I want them both to be 7.25 and we apply it. Okay, great. Now we can still go a little bit larger, so we will. And instead of 7.25, we're going to go 7.5. Okay, a little bit tighter. I think ultimately I will go 7.625, so it'll be 7 5/8. We'll apply it. That is pretty close to the edge. Then you'll have a little bevel, okay, and we'll do our cutout last. Now, let's take and let's highlight this whole piece. Oh, goodness, excuse me. Let's highlight this whole piece. Get it better centered. Okay. Come back, though, holding down your Shift key, and take off that outer bevel. Boom. Okay. He's gone. Now, we want to cut a tool path. We're going to actually do a V-carve here. I use a 60-degree for this. Okay, and this will be the clock face. Set your depth, 30, 40 thousandths, whatever you'd like. Calculate. Okay. We can take this off. And then the last thing we do is we just highlight our outer rim. We are now ready to cut the clock face out. Okay. Now, again, just like with the face frame, if you have this marked as either on or inside, because we originally did our bevel outside the line. If you do it inside or on, you're going to cut your bevel completely out. Now, again, my bevel was originally 120 thousandths. Okay? Well, this is a profile toolpath. This is the cutout. I know that I need to go 1.01 inches. I need to get my V-bit out because I'm doing a cutout with an end mill. I need to slow the speed of that end mill down. Now, in less dense material, pine, poplar, softwood, I don't worry too much about cutout, but I'm using a hard northern maple, so I need to slow the bit down. I've snapped them time and time again trying to push them too hard. Okay. Now, because we had a 120 thousandths bevel, like I told you before, my rule of thumb is I take half of that bevel, which is 60 thousandths, reduce another 10. That gives me a 50,000 offset. What that does is it will cut just outside of your bevel. It may come in and take just a titch of the bevel out. No big deal though. It still leaves you with a nice bevel on the outer rim. Okay. We also need to add some tool paths. Okay. 10 is a little too many for this. We can go with a half a dozen. All right. We add our tool, our tabs. We can close this out now. So we've got our depth cut at 1 inch and 10 thousandths. So we'll go through the material. We are outside to the right. We have offset it so we don't chop our bevel off. We have added our tabs, and we're going to basically call this cutout. Okay. Alrighty. Now, let's take a peek at everything. We're going to preview all those tool paths. There's our outer bevel. Okay. There we are. We'll set it all in black just so you guys can get a... And there you are. There's your clock face, noon, 1, 3, 6, 5 o'clock somewhere, So yeah, we're all set. We've done the back side. We've now done the clock face. Now, we're going to take this video up into the shop. I'm trying to keep this thing down. It's rather difficult when the first half of this is 36.5 minutes. But I feel that this is a pretty good learning lesson, and you end up with something at the end of it, okay? Well, now we're going to save this as... We can just save this as clock face. Okay, and it's clock face with tick marks, maybe. I don't know what you'd want to call those little browns, but... Okay, tick marks. Great. And now we're going to save it. Alright, we have successfully completed the clock face. The frame was done the other day. We're going to now take this into the shop, and we're going to show you guys how to put this all together so that when everything's said and done, well, guess what? You're going to have a nice clock to give to Grandma. Alright, guys, hang on. Thank you, everybody, so much. You've been great for hanging with me this long, and I hope I haven't bored anybody to death too bad. Alright, guys, we'll be back. Bye-bye.